Okay, good morning to you guys. Okay, so today we're going to start a new chapter, which is free statics. Okay, so we're going to deal with manometer today. Okay, part one. Right, before that, I review the definition of pressure. Okay, so pressure is actually normal force exerted by fluid per unit area. Okay, so force per area. So the unit is Pascal. Okay, or bar ATM or pound per inch. Okay, so for fluid static, we are dealing with fluid at rest. Okay, so there's no relative motion and there's no shear stress. Okay, so we only deal with normal stress, which is pressure. Okay, so so basically the pressure inside this fluid, the pressure inside this fluid depends on the atmospheric pressure and the hydrostatic pressure. Okay, so the pressure at this point, at this point is actually PATM, plus the hydrostatic pressure. So the hydrostatic pressure is rho GH. Okay, so this is hydrostatic pressure, right? So in gauge, we know that gauge is P absolute minus P ATM. Okay, so minus P ATM minus P ATM. So P gauge is rho gauge. Okay, so this is the pressure due to the liquid. Okay, due to the liquid. Okay, for this case, A, B, C, D, E, F, G have the same pressure. Because it is at the same level, right? However, I and H, although the same level, the pressure is different because this is mercury and this is water. Okay, so the criteria is the same level, the same fluid. Okay, so this is the absolute pressure. Okay, the actual pressure, the absolute pressure is the actual pressure. Okay, this is atmosphere PATM. Okay, so usually PATM is equal to 101.3. Okay, so Pascal, 760 millimeter mercury, 10.35 meter water. Okay, and also 14.7 psi. Okay, right, this is the value. Okay, the value of the PATM. The vacuum pressure is PATM minus P absolute. Okay, PATM minus P absolute. Okay, the gauge pressure is P absolute minus PATM. Okay, and can be positive. Okay, gauge pressure can be negative and can be positive. Okay, so if the gauge pressure is negative, then the pressure is actually lower than PATM. Okay, and the unit for gauge pressure is the same as absolute, but you put gauge at the end. Gauge at the end. Example, PSIG. Okay, so this is PSI gauge or KPAG. Okay, ataupun bar G. Okay, if it's absolute, you put PSIA. Okay, PSIA, KPA, A. Okay. Okay, so this is the relative position of the pressure. Okay, so this is vacuum. Okay, this is ATM. Okay, and this is absolute. Absolute. So P gauge is actually P absolute minus P ATM. Okay, so another way to measure pressure is called the pressure head. Okay, pressure head. So pressure head is actually the pressure, okay, divided by the gamma specific weight of that fluid. Okay, so you get the pressure head. Example, change the pressure of 350 kilonewton per square meter gauge into pressure head of water and mercury. Okay, so H is pressure divided by gamma. Okay, so the pressure is this. Okay, the pressure, the density of the fluid is this, and G is this. Okay, so you got 35.68 meter of water. Okay, so the meaning is that 350 kilonewton per square meter is equal to 35.68 meter of water. Okay, that's the meaning lah. Okay, and you do for mercury. Okay, you do for mercury. P is still the same, but you only change the density. Okay, so this is 2.62 meter of mercury. Okay, so 350 gauge is equal to 2.62 meter mercury. Okay, so we want to measure the pressure, we use the manometer. So this is the manometer. Okay, manometer. Let's say you want to measure the pressure of this gas. Okay, so you put some manometer fluid, let's say mercury. Okay, and then by measuring the H, you can measure the pressure of the gas. Okay, so P2 or P gas is equal to P atm plus rho GH. Okay, I will explain this later. So in a stack of layer of fluid, okay, let's say you have fluid 1, fluid 2, fluid 3. The pressure here is actually P atm, okay, plus the pressure by fluid 1, by fluid 2, and by fluid 3. Okay, so rho GH1, rho 2 GH2, and rho 3 GH3. Okay, so this is P1, right? So you sum up the hydrostatic pressure of that liquid. Okay, so there are five type of manometer. Okay, piezometer, U-tube, differential, inverted, and macro. Okay. Okay, example. So let's say you want to measure the pressure at A. Okay, the pressure at A. So we know that fluid at the same level, the pressure is the same. Okay, fluid at the same level, pressure is the same. So PA must be equal to the pressure here. Okay, so what is the pressure here? The pressure here is that P atm plus rho GH1. Okay, so that's why PA must be equal to P atm plus rho GH1. Okay. Okay, so now we extend this concept into U-tube manometer. Okay, U-tube manometer. It's called U-tube manometer because it's U. It's a U-tube. Okay, let's say you want to measure A, PA. How are you going to do this? Okay, there are actually two methods. Okay, two methods. Okay, I explain the two methods. Okay, the method one. Okay, you use the concept of the same level, the same pressure. So we know, let's say you want to measure the pressure here. Okay, the pressure here is just PA plus rho GH1, rho GH1. Okay, that is pressure here. and that must be equal to pressure here. Okay, so what is the pressure here? It's P atm plus, okay, so rho 2 G GH2. Okay, so and then you solve for PA. Solve for PA. Okay, that's method 2, which is actually simple, but for complex manometer it's difficult. So let's do method 2. Method 2. Okay. So let's say you start at A. Okay, you start at A. So you write PA. Okay, and then you move vertical, move horizontal. Horizontal to a point, this point, point 1. Okay, and then you go down. Okay, when you go down, the pressure will increase. Okay, when you go down, the pressure will increase. When you go down, the pressure will increase. So you plus rho 1 G H1. Okay, so you go down, go down. Okay, and you go down again. Go down. Okay, horizontal, and you go up. When you go down and you go up with the same height, it cancel out. So this is plus, this is minus. Okay, when you go up, it's minus. So cancel out. The pressure cancel out, and then you go up. Go up from this point. So when you go up, it's minus, because your pressure will decrease. So P2 G H2. Okay, and finally equal to P ATM, P ATM or PD. Okay, so there are two methods. You use this method 2, method 2, because method 2 is easy. Method 2 is easy. Okay, so you solve for PA, you get this. Okay, PA equals PD plus this and this. Okay, so PD is open to hemisphere, then PD is PATM. Okay, right? Okay, so let's say this gray fluid is gas. Let's say this is gas. So for gas, you can neglect the rho GH. The rho GH can be neglected. So PA equals PATM plus gamma 2 H2 minus gamma 1 H1. Okay, this is from before. This is from before. So we know the fluid 1. Okay, fluid 1 is gas. Okay, so if fluid 1 is gas, you can neglect the hydrostatic pressure. So this is 0. Okay, gamma 1 H1 0. 0. Okay, so if this is neglected, then we get PA minus PATM equals gamma 2 H2. Okay, or equals to PA gauge. Okay, because PA minus PATM is PA gauge. So PA gauge is just gamma 2 H2. Okay, this is for gas. If this is liquid, you cannot neglect the gamma 1 H1. Only if A is gas. This is gas. So example, let's say you want to measure the pressure of air here. Okay, what is the pressure of air here? Okay, use the same concept. Okay, you go down, up until you reach the outside, right? Okay, so you go down. Okay, you go down. P air plus, okay, plus water G H1, okay, plus okay, so PA plus rho water G H1, okay, you go down, go down again, plus rho water GH2, okay, you go down, okay, plus, and then up, okay, up, so cancel up, okay, so cancel up, you go up, minus P water GH2, okay, you go up, rho oil GH1, okay, minus plus, okay, minus plus, so cancel out, so you go down, okay, you go down, one, okay, and then you go down, plus rho oil GH2, okay, then plus, minus, okay, and then you go up, mercury GH3, okay, so that must be equal to PATM, PATM, okay, so you cancel out, okay, so this is cancel out, cancel this one, this will cancel, okay, and finally, okay, this cancel, and you get the following, okay, get the following, after cancelling out the plus and minus, you get this, right, and solve for P1, okay, so MP1 and substitute the values, okay, substitute the values, and then get P1 is equal to 130 kilopascal, okay, so that's the way to solve the manometer problem, okay, right, so now is another manometer, it's called differential manometer, okay, differential manometer ni is you want to find the difference, the difference of PA and PB. Okay, so that's called the difference manometer. Okay, so let's say you want to find PA minus PB. Okay, so again you use the method number 2. Okay, PA plus A plus A plus minus cancel, go up, minus, okay, minus, and go up again, minus, okay, and dash PB. Okay, and you solve for PA minus PB. Okay. So this is the differential, the differential pressure. Okay. So let's say the density of A and B are the same. Okay, so rho 1 equals rho 3. Okay, and then you solve. Okay, so solve for PA minus PB. Okay, another differential manometer is that you want to measure the pressure in the upstream and the downstream. Let's say you want to measure P1 minus P2. Okay, okay, P1 minus P2. So the same concept, P1, you go down, okay, go down, okay, you go down. So plus rho 1 G A plus H. Okay, it's vertical, vertical height, not this length, height, vertical height. So A plus H. Okay, so that this is the pressure. Okay, so plus minus, go up. Okay, go up. So rho 2 GH and go up again. Okay, rho 1 GA. Okay, so you get equals to P2. Okay, so the difference in pressure is this. Okay, P1 minus P2 equals the difference in density times H. Okay. Okay, the same thing. Okay, the only difference is that the pipe is inclined. It's not straight pipe, but the concept is the same. Okay, you can try to do this. Okay, this concept is the same. Okay, so this is the manometer that use the manometer on top of the pipe. Okay, on top of the pipe. The same concept. Okay, so you start with A. Okay, when you go up, minus. Okay, minus gamma 1 H1. Okay, so minus, plus, so cancel. Okay, so this is also cancel, plus, minus. Okay, so this you go up, minus rho 2 H2. Okay, cancel out, and then you go down, it's plus, plus. Okay, so rho 1 H1 plus H2, this is the height, and then reach PB. Okay, PB, and then solve for PA minus PB. Okay, so you can try this problem 3-4 in Chengel. Okay, this is called the inverted manometer. Inverted manometer. Okay, you try. Okay, the same concept. Okay, so now this is the inclined tube manometer. Okay, there's an angle. There's an angle here. Okay, there's an angle here. So the same concept. Okay, PA, go down. Okay, but we are not measuring the length. We are measuring the vertical height. The vertical height. Okay, so this height is L2 sin theta. Okay, the height is L2 sin theta. That's why minus, okay, minus gamma 2 L2 sin theta. Okay, it's not this length, it's not this length, the vertical length. Okay, Okay, so minus gamma 2 H3 vertical height. Okay, and then reach PB. Okay. Okay, so any question?
Doctor.
No question?
Oh,
Okay, so if there's no question, we'll continue. We'll continue with the forces due to aesthetic forces on submerged plane surface. Okay, so let's say you want to measure the force on the dam. Okay, how are you going to do this? Okay, so basically, the one of the terms, okay, that we're going to use is center of pressure. The center of pressure is the net force on the submerged surface. Okay, the net force on the submerged surface. So let's say you want to measure the force on this surface, on this surface. So you must sum up all the forces from this point until this point. Okay, it's not point, it's continuous. So it's difficult actually, because at this point the pressure is P ATM plus this H1. Okay, but at this point the H is different. Okay, so there's a variation of the hydrostatic pressure. Okay, so how are we going to do this? Okay, so we are going to do this. Okay, so the resultant force, okay, the resultant force is just P naught, okay, plus rho GH sin theta. Okay, let's go do this. So let's say you want to measure force here. Okay, let's say you want to measure the force here. The force here is actually pressure times area, right? The force here is pressure times area. Okay, so the pressure at here is actually rho P naught plus rho GH rho GY sin theta. Okay, why sin theta? Because we want the vertical height. We want to get the vertical height. Okay, vertical height. Okay, so that is the pressure. Okay, times area. Okay, times area. Okay, but you need to sum up. You need to sum up all the forces. All the forces. So to make things simple, the FR is just this. Okay, P naught plus rho GH YC sin theta. Okay, times the area of this surface. Okay, and YC is the centroid, the length of the centroid. The length of the centroid. Okay, the length of the centroid. Centroid is the middle of the surface. Okay, YC. YC is measured from here 0 to here. Okay. AC is the vertical height. Okay. AC is the vertical height. Here. Okay. Right. Okay. So FR equals P naught plus rho G YC sin theta. Okay. Or P naught plus rho G AC times A. Okay. If you know the A and you know the height of centroid, you can calculate the FR. Okay. Now, where is the center of pressure? Okay. First, you get the FR, and then you want to find the center of pressure. Okay. In order to find the center of pressure, you write center of pressure YP equals YC. Okay, that is centroid plus IXX. Okay, IX is called the second moment of inertia. Okay, second moment of inertia, which depends on the area of the surface. Okay, and YC is the centroid Y. Okay, okay, and times A. Right. Okay, so this is the value of YXXC for various geometry. Okay, for various geometry. Okay, so for this rectangle, your YIXX is AB to the third divided by 12. Okay, whereby the A is the horizontal, B is the vertical. Right? Okay, for circle is this pi r to the fourth over 4. Okay, okay, example. So a heavy car plunges into a lake during an accident and lands at the bottom of the lake on its wheels. Okay, so the door here is 1.2 meter height, okay, and 1 meter wide. Okay, and the top of the door is 8 meter below the surface. Okay, so this is 8. Okay, so determine the acidic force on the door and the location of the very center. Okay, and discuss if the driver can open the door. Okay, okay, so so if you remember, Fy equals AC, right? Okay, so the whole thing times area. Okay, times area. Okay, so first you must find the what is HC. Okay, what is HC? Okay, HC is the centroid. So we know the height is 1.2. Okay, 1.2. So in the middle, okay, the middle of the 1.2 is 0.6. Okay, 0.6. So the HC, okay, HC is 8 meter plus 1.2 over 2, okay, or 0.6. Okay, so that is the centroid. So this is the centroid. Okay, so this is the centroid. Centroid. Okay, so this is 0.6. Okay, so this is 0.6. So the height of centroid is 0.8.6. 8.6. So next is calculate the area. Okay, so the area of the surface is just 1.2 times 1. Okay, okay, 1.2 times 1. So that's the area. Okay, and then we put in the gamma water G, gamma water and G. Okay, okay, so for this case we eliminate this P atmosphere. Okay, cancel. Why is cancel? Okay, because okay, so let's say this is the door. Okay, so this is the inside. Okay, so this is the water. Okay, so the actual pressure here is actually P naught PATM plus rho GH. But in this case, in the car, there's some MS pressure. So this is P naught. Okay, so P naught times A cancel out with P naught times A at this point. Okay, so that's why this is neglected. Okay, neglected. Okay, so you get this FR, FR. So this is your FR. Okay, so now you want to find the YP. Okay, YP. Okay, so how to find the YP? Okay, so you use this formula, this formula. Okay, yp equals yc plus ixx over yca. Okay, okay, so I see yp equals yc plus ixx over yca. Okay, so the trick is to find ixx. Okay, ixx and yc. Okay, right. So also y equals h if the angle is 90 degrees. Okay, 90 degrees. So in this case, 90 degrees. Okay, so yp equals, okay, so what is yc? So yc is just 8.6. Okay, okay, from here to the centroid. 8 plus 0.6 plus what? AB to the third divided by 12. Okay, divided by 8.6. Okay, times area. So the area is 1.2 times 1. Okay, so the A is what? Okay, A is the horizontal, so 1. B is the vertical, so 1.2. Okay, so solve. You got 8.61. Okay, 8 point. Meter. Okay, okay. Why this 90 degrees? Okay, because when you look at the front, the surface is like this. The door, okay. So 90 degrees, 90 degrees. Okay, the door is like this. So the angle is 90 degrees. If the door is like this, let's say from the front, the door is like this. Okay, then it is not 90 degrees. Okay, okay. Let's say this is 60 degrees, 60 degrees. So for this case, y is not equal to h, right? Right, so h divided by y is equal to sin theta. Sin theta. Okay, so any question? Okay, so to conclude, in order to find the force on the submerged surface, submerged plane, okay, the first thing you must locate the centroid, okay, the centroid of the area, okay. So let's say your door is like this, okay, your door is like this, the submerged surface is like this, so the centroid must be here, okay, the centroid must be here, okay, so centroid, okay. Okay, if you want to find the centroid is here, okay, so locate the centroid of the geometry, okay, determine HC, okay, HC is the vertical distance, okay, vertical from the surface. So let's say this is your water, okay, and this is your surface, okay, your surface. Let's say this is 90 degrees, just like the door, okay. So HC, what is HC? HC is just the distance here, okay, plus the distance here, okay, so that is the AC, okay, so this is the AC, right? Determine YC, okay, so you know that the Y over, sorry, H versus Y equal to sin theta, okay, for this case the angle is 90 degrees, so let's say you from the front it's like this, okay, So the angle is 90 degrees. Okay. If not, use this formula. AC equals YC sin theta. Okay. So the fourth is calculate the area. Okay, calculate the area of the surface A and calculate the FR. Okay, FR. Okay, so FR equals gamma HC A. Okay, okay. So the atmospheric pressure is cancelled out, because the atmosphere act on this one and act on this one. Okay, so cancel out. Then calculate IXX. Okay, the moment of inertia. Okay, depends on the geometry. And then calculate YP. Okay, so we know YC and we know IXX. Okay, and we know the area. Okay, so we get the YP. Okay. Okay, if there's no question, I think that's enough for today. Okay. Okay, so that's enough for today. So no question? Okay, if there's no question, we conclude this lecture and I see you on next Tuesday. Oh, next week. Next week is the test, eh? So I think I want to postpone the test. Okay. Probably 1 week. Okay, 1 week after the initial test date. Okay. So for the test, cover until here. Okay. For the test, cover until today's lecture. Okay. Right. So until hydrostatic pressure on submerged plane, submerged plane. Because on the next topic is that next topic is on the submerged curved surface. So for the test one, until hydrostatic force on the submerged plane. Okay, submerged plane. Okay, manometer included also. Okay.
Okay, doctor.
Okay, is there a problem? Okay, see you on Tuesday.
Thank you, doctor.
Thank you, doctor.
Okay. Okay.
Thank you, doctor.
Thank you, doctor.
Thank you, doctor. Bye bye.
Thank you, doctor.
Thank you, doctor.
Doktor,
Ah,
saya Cynthia, saya ada soalan tentang assignment 1.
ah,
Yang soalan 3 kan, statement ayat baris ketiga, dia kata assume the temperature is 70 degrees Celsius and the pressure is 14.7 psi absolute. So, dalam statement ini kan 14.7 psi equal to 1 atm kan. So, sini doktor tak ada mention itu pressure ialah atm. So, saya boleh assume pressure itu sebagai atm at sea level.
yes, boleh, boleh.
Okay, thank you doktor.
Okay. Right, so no other question?
Tak ada.
Tak ada, okay.